Patrick, I did go to your website. I see the placeholder there. I thought we could start just by you introducing your group to the rest of the team. They don't really know exactly what you do.
What do? We run a consultancy company since the pandemic, almost solely focusing on Filecoin mining and Filecoin data onboarding. But yeah, we enable Filecoin miners basically top to bottom, from idea to mainnet mining operations.
Right. And what if, on Filecoin, is it just I don't know, I assumed that it was more than mining, that you had expertise in all the areas of Filecoin, or is it just the mining aspect?
We have expertise in all, be it data onboarding in a certain scale, as the network limits that right now due to the software capabilities and availability of data. But we onboard data to our help clients to onboard their data to the Filecoin network and build their applications on top of it.
Okay, that's exactly what we need. And how much of the information that I sent you were you able to review?
From what you sent me, the let me call it the pitch deck. I'm not exactly sure if it's your pitch deck or not, and where exactly you stand in your operation right now. What isn't clear to me is where Filecoin comes into play. I get you build the blockchain based, well, you call it a time machine. Let me call it an artsy thing, entangled with quantum mechanics and technology to open the mind and expand the mind. I'm not sure where your Filecoin mining operation. You said you trying to set up a Filecoin miner. Where exactly plays Filecoin into your project?
Okay, let me introduce you to H.A.L.O. This is H.A.L.O. So this is a ASUS motherboard. We currently have 2 GPUs in there, but it's capable of hosting 3. And we have a third GPU, it's just not plugged in. So we generally run 2 NVIDIAs and 1 AMD. It's got a full stack 128 of memory. It's the Tough RAM RGB. And then we have a Threadripper. This is a Threadripper platform. Currently, we're running the 1920X, which is a 12-thread CPU, which is upgradable up to 128. So the 64 core, that's going to run us around $5,000. And our goal is to actually build another one of these with a much larger, this will probably stay where it is, and then add on to it with another group. We also have, like Dr. Caputi right now has a laptop, which is also a ASUS ROG laptop, which will be running as an extension. So what we're building is it's called a neural lace network. And if you see, I'm going to do a screen share. If you look on top of the computer, you kind of see the bottom of this. And what I'm going to do is share my screen. And this is the program. Are you able to see that?
Yes, I am.
Okay, so that is q-byte processing. And where Filecoin comes in is we're creating, when I say neural lace network, part of that is application-based, and it's also individual AIs. So what we want to do is basically, if somebody comes to our website and they want to activate this clock, they would log in with NEAR. And if you read the white paper, we've already minted 3 different utility tokens on the test net. And the one reserved for this one, for this application, we call U64 max. So I'm sorry, U128 max. And that is the single largest number you can actually put on a 128-bit encrypted system. And so I think it's like a 38-digit number beginning with 3. And what we want to do is utilize this clock. So this is a clock that will tell you the time. If you read the numbers at the top, that's UTC time. And the numbers at the end, we're measuring an electron as it passes through. The graph on the top is, you see 9, actually there's 10 different signals there. 8 of them are coming from individual quantum devices, the random number generators, and 1 large one. So there's 9 different inputs. And basically what we want to do is take the output of those 9, put them right into a Filecoin API and CID system, to where we have a core. Are you familiar with the Octopus network or Polkadot?
Briefly.
Okay, so it's a substrate system. The Octopus is basically a Web3 version of Polkadot. So we're creating a substrate based on this core data. So our core substrate is going to be the raw data that comes out of H.A.L.O, and then our app substrates will be the front end, will be pulling that data in various different applications. And our first one is this clock. So when I say time machine, every clock is a time machine, right? And this one actually is quite unique in that I would say we solved a problem that emanated from Princeton in the late 70s and early 80s in the electron tunneling phenomenon. They had an entire department dedicated to its study for decades, and closed the department with no significant results to report at all. And so Danny and I really took up the mantle on this project, and we were able to create this. And this is the first tangible application of this. And if you look at, we've already proven it in a global competition in a sandbox environment with machine learning. We use this data to improve the accuracy of COVID-19 outbreak rates around the world in an algorithm. It's open source. It's on our GitHub under X.Prize that utilize this and weather data to create an algorithm that measured 128 or 200 and what is the number again? 235 regions around the world.
Yeah, 235.
235.
Basically, the regions were countries for the most part.
Yeah, and then it ran for 20 days, 180 days out, 7-day average. Of the 104 teams that competed, only 80 of us were able to finish both models. So it was a very complicated, very difficult task. Mason and Danny were integral into doing that, into making it work. And so you can see it replicated on our haloai.me site. If you go to the X.Prize, you'll see a clickable version, and you can see the model actually at place. And with that, we finished the competition. None of the judges, and they still don't really know how it works. We know how it works, but they don't understand how it works. And so we were invited to the X.Prize alumni network. And let me see here. We were invited to the X.Prize alumni network, and where we still are, which we're the only quantum computing and the only blockchain project there. Do you know what X.Prize is? Have you heard about it?
I've heard about it.
Okay.
Yes.
So Elon Musk just put in $100 million for the X.Prize carbon removal process, and we might be participating in that as well. And we actually might be, we had a meeting with the alumni network. There's some major players in this too, to potentially build or lead the development of a X.Prize DAO for internal networking. So this could have a huge impact way beyond even our own individual projects, in that if we can empower, we really want to empower the blockchain, the X.Prize community with the power of NEAR and anything else we can put into it. So there's a lot of opportunity here, and we're already pretty much there as far as the relationships go. So basically what we, at our basic levels, we want to take what you're looking at now in some form. Now I'm going to click around on this a little bit. Hold on. So like on here, let me see here. It's got a couple of different views. So that this is the quadratic array view, and we can move these around. And so these are digital versions of what we have planned to actually make in the real world as well. And so here's the hypercube and the sphere. This is the sphere. We can move this around. And so what you're looking at is data visualization of all this raw data up here. By the way, Danny, look at this very unusual trend. Look at that lower trend. That is really unusual.
The red?
All of them. You see how they're all drifting down? Yeah. So, and then here's the pyramid. Let's do this.
Oh, by the way, Leo, I think you said of the 104 teams that started, 80 of them finished. It was actually 20, I think.
No, 80 didn't finish. Yeah,
80,
did I say that wrong?
I think you
Sorry.
said 80 finished. And
Oh, yeah. Only 20 of us finished, and we were the only ones doing quantum anything. Yeah.
Yeah.
So we want to get some version of this. There's two things. We need to be able to get the output of this onto Filecoin, and then we need to create a version, ideally, and we're really stretching the limits of I think, or exploring the limits of the Filecoin, or not Filecoin, but the NEAR network, which Filecoin is a part of, obviously. And so we want to basically charge people. We want to create a correlation between the how would I put this? The smallest measurement increment of time that we can achieve on the chain, and we want to charge that per smallest increment of coinage that we can create. And so there's a little token engineering there where we have to assign a value to the token somehow through staking or however it is. I'm not really sure on that. And then get this. So we want, when somebody signs up, what we want them to do is be able to come on, look at a basic version of this running on the web. And then if they want to log in and be a part of the system, they can log in with NEAR. We would charge them, you know, the X amount for whatever use. Now, I'm guessing somebody could buy like 100 years worth of time on this, and it would still be less than a penny, right? So we want to charge the absolute least amount we can for this, because this is a utility. And other applications will have other uses, but with this, so let's just say if the lowest increment of time we're able to process is a nanosecond, then we would charge 1 nanosecond for every 1 time coin. That's what we're calling the time coin. And then so as it's passing, if 10 nanoseconds passes, that costs 10 time coins. And then when they're logged on, all of the output data that they're reading is actually being saved into their own CID, their own repository. So when they create an account, they're capturing all of that data. And then later on, or we could do it now, but we eventually want to be able to, because when they're capturing that data, there are words involved. So if you look, have you noticed the word? Let me switch this thing. So if you notice, there's a word showing up. And so integrated into H.A.L.O is 130,000 word corpus that we acquired from Gesundheit.
Thanks.
That we acquired from BYU linguist. And so this is currently set up for every second that passes, a word is selected. And then that word is saved into a text file. And so we want to be able to do the same thing. And then, so every person who's using it is going to get a different series of words, and those will build up into eventually into its own natural language processing system. So a person will be able to have a discussion. At first it'll be one way, eventually it'll be two way, but they'll see words coming out them that'll be unique to them. And we'll be able to save that. And now where the future comes in, where we kind of mocking or jokingly call it a time machine, is that if somebody wants to sit here, now what you're looking at is just one word, right? But what we eventually the interface will have, there'll be about 10 words. And this will sample 48,000 or 86,400 words a day. That's a lot of words, right? And some of them are going to show up more than once. And so what we're actually doing is going to be featuring the higher frequency words. And so the final version, somebody might be looking at a display of 10 words, and one of them changes on a regular basis, but there are words coming at them as the data changes. And so somebody will be able to say, oh, that's pretty cool, but this is really slow because they'll be working on actual time. You know, it's still 86,400 words a day, but the numbers are still going to update relatively slowly. So somebody could go in and say, okay, well, I want to now purchase 100 years of work, or 1,000 years, or 1,000,000 years, or 1,000,000,000 years, or 1,000,000,000,000 years, whatever it is. We don't even know how to say the number. It is so big. It's like a gazillion. We call it U64 or U128 max because we can't, there's not a way to say it. But conceivably, somebody might be able to purchase something like that. The time, the amount it would cost is built in. So somebody could conceivably pay hundreds of dollars for future time. And then when they activate that, what that would do is basically they might buy so much time, it could take 6 months to run it. But what they would have is a dashboard that would be constantly updating. And then the reason why it's a time machine is they'll be able to, for any of the amount of time that they've already purchased, they would be able to basically with the scroll to a date and see what the words on that date are, or a range of dates. You know, so somebody could say, oh, I just want to, let's say they want to look at the year 2030. So they just like, okay, I just want to do the year 2030 and purchase that. And that would be its own little package. Let's call it a CID. And then they say, well, now I want to use the year 3752 to the year 3797. And then they create that CID. And then we want to be able to basically give them the opportunity to crunch those together. And somebody could actually mint their own. Now, this is where we improve, and this is beyond the scope of our like right now. But I would say the next phase after we get this, we'd want to be able to, somebody could go in and mint, take all of their nodes that they collect and mint an NFT. And it would be like a little AI NFT that has a package of all the words that they crunch together. And then that would continue to reside on the blockchain and act as a node on a larger neural network. And so if you had thousands of people doing this, you would have a language processing of monumental size. Okay, so I'm going to stop. Are there any questions before I stop sharing this?
The data in the top right is directly connected to the words.
Correct.
Meaning, if I get by chance the same set of data, I will get the same word.
It's impossible.
To get the same set of data is impossible.
Yeah, you wouldn't get the same. You really wouldn't get the same running 2 times. You wouldn't get the same output running.
No. I mean, if I take a single data point, not a single data point, like a vertical cut of those 10 graphs, they all represent 1 data point. So I have a set of 10 data points. If I take them and look at them, do I get the same word? If it's, how are the words generated from the data is my question.
So this is where, and Danny can explain this a little bit further on the technical aspects, but I would say conceptually, this is where q-byte processing comes in. This is a key concept to what we're doing. So on top of the computer, I'll show you right here. These are actually what is reading it. Oops, let me see here. Right there, there's 4, and there's the other 4. And then this is what we call the turbo, right? And so
you can actually buy those.
Yes, they are commercial grade cryptographic cryptography tools.
How many bits are in there?
What's the capacity, Danny, for all 9?
It's close to 1,000,000 bits per second if you put all 9 of them together. The small ones are not quite as fast, but they're still, it's like 50,000 bits per second. It can go up to something like that.
Okay, and let's say they generate the same output twice, as we are talking about 1 trillion years. Will I get the same word in the end? How is the word correlated to the output?
So what's happening is, as those, I'm just going to use the 8. So obviously you understand a bit and a byte. And so in the quantum computing world, quantum computing, they process q-bits, which is a 4-digit bit, right? We developed this completely on our own. This is why we call it hybrid quantum computing. And what I'm going to switch this off so you can see me. Stop share. Okay, and I'm going to switch the camera. All right, so we have 8 bits, right? And our database is set up to where, right, currently the idea behind it has 130,000 words stratified over 9 different categories, right? And those 9 categories are their appearance, and we have the frequency of how they appear. And if you look at this figure right here behind me, and it's this shape, it's the hypercube. This has 30 sides, right? And so our database currently has 9 categories, but it has 30 set up. The other right now are just blank, and those will be filled in with usage, right? So every second, now we could do it 100 times per second or 1,000 times per second or whatever, but we have it set up for a second now. Every second it goes out and takes a sample of all 8, right? And so it's binary code 01010101. Once that is snapped, that is correlated to a word on the database, and that's what comes up. It's from those 8. So if the exact same 8 showed up in the exact sequence, it would pull up the same word.
Okay.
Yes, and that's why we have more words show up in frequency. It does.
Yeah, sure.
But it doesn't. But we don't have control over that. This is what we call non-deterministic AI, because we have an output, and that's what we're working with. What we've done is, with our sampling method, we're using mathematical constants to kind of sift out the chaos, the randomness, and identify slipstreams of data. And that's what we're sort of keying into. And then on the individual basis, so when I say no 2 people would have the exact same experience, that they wouldn't, because it would be seemingly impossible for 2 people to get the same outputs from 2 different locations. Yeah, there's like too much there. And so this is a kind of a consumer grade version of superposition processing, right? Now this is a clock. What we're basically creating is a clock and a clock speed and a core decentralized AI platform that we can build upon. Anything that uses time as part of it, which all applications use time as part of their application, could be integrated in with this in a lot of different ways. And so this is the time machine aspect is really just the first part of it. And then eventually we'll add more substrates on it. Every application we have is a different substrate. So it could be an art gallery. It could be, let's say if we had an art gallery and somebody came to the website, and they wanted to see 100 works of art, q-byte processing would actually select which 100 works of art they would see. And everybody coming in and seeing it would have a different setup. So every user would have an individual experience. It wouldn't be one experience fits all. And so
how much data is that generating?
A lot.
Yeah, a lot is relative.
It depends on how much we want to capture. It kind of depends. We haven't actually, I don't even know. Danny, have we done an experiment where we captured everything? If we set it at maximum and captured everything?
Well, we're kind of limited by the ability to write to a text file the way we have it set up. You know, like I've said in the past, if we wanted to adjust the writing process, I could probably do it more efficiently writing to binary, but that would involve going in and engineering some things in the Python code. So, but
Right.
yeah, I mean, we could conceivably do a test where we're doing the maximum rate or close to it.
And we do have all of, like, we have a Lotus Notes installed. We can run daemons on both of our computers. We have most of the, I think we have all the components installed. We have a near validator installed. We have the Octopus substrates. We actually won the Octopus, the last meta build hackathon. We won the Octopus substrate challenge. That came with $10,000. So like the people at Octopus paid attention to us. We're probably going to be going through the Octopus accelerator in a couple of months when that starts back up. And we're in 2 hackathons right now. One of them has a Filecoin prize. And that is the Morales. So I posted that in as well. So by the end of the month, we have to submit however far we get in this application. And ideally, we'd want to output as much as possible and that is feasibly possible. Let's just say not for application reasons, just for scientific testing reasons. We'd want to like test the maximum. It's like, how fast can we put this output onto the Filecoin? And what we want.
That's why I'm asking if you are limited by pure physics. Let me say it like that. If you can generate more data, then you can write to a disk. If you can generate more data, then you can write to the internet. Let me call it write to the internet.
Yeah.
You have to get it to the Filecoin miners or the Filecoin network. Let me say it like that. To actually store it on Filecoin.
Yeah.
You are building a massive data generator in the end.
Yeah.
That now centralized in your, what is it, in your workshop behind you. You have to get the data out of your room to the Filecoin network.
Yeah.
And you need some processing power. I believe you have enough processing power to actually process that data to get it on Filecoin. But you will have physical limitations on what the Filecoin network can do right now, what an internet cable can do. Throughput. That's why I'm asking how much data this is generating.
And we can throttle that down to, you know, obviously whatever works. And we have the concept. We in the X Prize competition, what we did, because it was a sandbox, you know, we were not allowed access to it during the competition. So what we did was we used what we call pre-time, and we preloaded a timeline of data to just sit up there. So we can do that with this as well. We can preload a year or maybe a decade worth of data that can reside on the network. Let's just say we did 10 years of pre-data, that we would have this running live. But if for some reason, let's say there's a huge internet outage and we can't log on, then it would default to the pre-data that was there. And so, yeah, we just want to, like, in terms of these early stages, this is more like in the scientific exploration. We don't want to necessarily, you know, we're not doing this to maximize profits or anything like that. We want to just get this up and running and working, and then orchestrate and engineer an efficient system, whatever is the most efficient. Now, part of my background is I was in the Navy. I was a power plant engineer, so I was supervisor qualified on warships to run their power plants, complex interrelated systems. You know, you can't push everything at once. You have to find an equilibrium and balance, right? And so that's kind of what we have to do here. And we want to add more laptops to the system. So eventually what we'd want to do is have other people on the network say, hey, I love this idea. I want to be part of this. So I'm going to buy a $10,000 network. I'm going to buy a $10,000 computer. I'm going to hook it up. I'm going to put 10 terabytes onto the Filecoin network for storage. I'm going to participate in this system, put in a miner, and this computer will then help pay for itself while adding to the network and being able to access our applications. The way I understand it is if we're actually providing the mining, I got this from some of the videos I watch. If we're developing projects and we're providing mining services as a group, a lot of the processing that we can handle locally rather than taxing the system, right? So ideally, we'd want hundreds, if not thousands and thousands of computers tied into this network and contributing both on the mining, storage, and the utilization of the applications. Seeing this in person, you kind of get an idea of it online, but it's not, when you actually are looking at it live over time, it's quite profound. Because one of the things it does, there's an underlying nature to reality that a lot of people sense is there, but it has yet to be defined in scientific terms. Einstein studied it for basically his whole life in the nature, the spatial quality of time, right? If you look at Einstein's, there's the general relativity, there's special relativity, and then there's quantum mechanics, and they don't really all mix together until now. So this device unifies the laws of quantum mechanics and relativity, and we create something called spatial relativity. So just by using this clock and by watching it, the users will gain a better understanding of the nature of reality and how time is actually structured. And because we're measuring time dilation without a secondary frame of reference. And so that's one of the powerful things is somebody, and August can testify to this. August saw one of our installations at an outdoor camp out over the summertime and was just captivated by it, knew there was something there to it, didn't quite know. And then after we explained it, he had an oh shit moment and says, I want to be a part of this. Right, August, did I contextualize that correctly?
Yeah, no, that sounds right. I mean, it's just it's an odd thing. I was wondering, I was like, okay, we need to be clear on what Filecoin is getting used for. But the technology itself is a really interesting, very interesting proof of concept of something that is not easily articulated outside of the abstract, which is what caught my attention so thoroughly.
Your challenges regarding Filecoin will be to outline a clear use case. So the problems I see right now, if you install a Filecoin miner on the machine behind you, you have a month of full-time work to get it running and not actively lose money on it. Filecoin mining is a pretty complex, nasty task. Let me say it like that. There are risks involved. It's not Bitcoin mining. It's not turn it on and go, but for now it's a pretty active task to do. So the question is, if you want to have that on there, if you really want to do Filecoin mining on that machine, even if you scale the single machine up, or at the second one, you won't get a lot of throughput. With the computer behind you, with the 12 cores and what you have right now, you maybe store 100 gigabytes a day, maybe 256 gigabytes, but that's about it. With the processing power you have available there, it's definitely possible to just store the data locally.
Well, I would say for us, the mining is a secondary component to actually serving the application. Serving the application is the most important part. And then my thoughts on the mining was, if we were able to mine, that would help augment that process.
I doubt with the hardware you have there, you would get more than $1,000 out of it in a year with the current Filecoin price, maybe even way less. So if your main purpose is serving the data to the application, using IPFS, Filecoin itself, it's slow storage. As by now you cannot feed an application with it. It takes a tremendous amount of time to get the data out of the network. Once it is in there, both directions are terribly slow right now to store. And Juan, who invented IPFS and Filecoin, actually sees IPFS as the delivery layer on top of Filecoin. So we would actually need to look at how much data you want to generate, how much you can generate, how much throughput you could get for Filecoin storage on your own machine, and how much data you could get out, if that would be sufficient for the application itself. But in the end, Filecoin is cold storage. That's I definitely see it for if you say you want to put 10 years of data on there, like as a backup, but most applications target a two-layer approach of storage and retrieval. We have IPFS as the hot storage. Let me say it like that. So application can actually access the data in a reasonable time frame, and Filecoin as a lower backup layer to permanently store the data on the Filecoin network, but then always go through the layer of IPFS to retrieve it. If you actually want to use the data you store with Filecoin, you will have a hard time, at least for now. And the mining experience is not great. So it would need some engineering on what exactly you want to do, like a data flow diagram. Where's the data coming from? Where is it going to? Who needs the data? Do they need? Well, it's a clock. Live data would be nice. Let me say it like that. But I rather see the layer your application is interfacing with on IPFS.
Well, some of the early videos that I watched, people explaining this, somebody made the comment that you could host code on IPFS and Filecoin. Are you saying that that's not possible? That you can't run can we have our code written in Rust sitting on a GitHub page application, and that people can basically activate from there, and then that would pull in the data from Filecoin?
That would work. It's just terribly slow with Filecoin itself right now.
Yeah. So I've actually started to test this idea of uploading to do you know web3.storage?
Yes.
Yeah. So I've been uploading stuff to that. I've set up a way to upload automatically with the Python script and then retrieve from it on the other side. And it works. It's fast enough for what we're trying to do. So I'm not too worried.
It's fast enough because it uses a two-layer approach. So it keeps your data on IPFS and backs up that data to Filecoin to get permanent storage, as IPFS is some kind of non-permanent storage. So it has the 2 layers. If you would store with Filecoin, you would see delays of 6 to 8 hours for actually storing something until it's permanently stored on Filecoin. So it's a hot storage, cold storage approach, all, be it Web3.storage or NFT.storage, I think it's called, and S.C.R.E.A.M, the 3 platforms actively doing it. They basically take the data locally and then gradually push them to the Filecoin network, but they build a layer between the user and the Filecoin network to exactly challenge those speed problems Filecoin itself has. I don't know if you have experience with Amazon storage. They have their Glacier storage where you need to tell them 12 hours before that you want your data. And the more hot storage tiers to get fast access times to near instant access. But going through a platform like Web3.storage would be the fastest way to utilize IPFS and the Filecoin network, as they have done the engineering work, let me say it like that, of connecting those 2 layers, and would just take your data and take care of it being stored on the Filecoin network for free right now.
Okay.
If you want your users to store their own data from wherever they are generating data, where that data is, it might not work with the platforms we have right out there, and you need to find your own solution of building that layered system for storage. But Web3 is not the only one. There's S.C.R.E.A.M, basically doing the same thing, building a buffer between the Filecoin network and the actual application running that. But then I see no problem getting the data out to your users or your applications.
Yeah, so that actually, that kind of brings me to one of my, I guess, key questions. And maybe this is probably, I don't know, this is probably either really simple or it's just one of the issues. I'm not entirely sure, but it's like when you upload to Web3.storage, it gives you a CID. And my understanding is that CID is based on the hash of the actual file. So like, there's no way to say, okay, I want to store something under this CID, because that's just determined by the file. And further, there's no way to say, let's say I upload a directory of files. There's no way to append that directory once I've uploaded it, because it's on the blockchain, and that would kind of defeat the whole purpose, is if you could upload the same thing with the same storage. So I was trying to look into, like, let's say that on H.A.L.O, right, the machine sitting behind Leo right now, I want to set up an automated system where every hour it's pushing a data file to Web3.storage, right? I could do that pretty easily.
Yeah.
But then if I want to retrieve it on another side, I need some way to access a list of all the CIDs that it's uploaded. And so I'm not sure, is there a way that I can, using like the command line or something, like get a list of CIDs that were uploaded under a certain token?
I'm not really familiar with Web3.storage, as I never used it, but I believe they when you upload it, they must return you that SID
They do return it, but like what I want to do is, because if I want to run a Python script on my end here,
Yeah.
let's say, well, that's there. It has to know what the SID it looks for. And so it would be easier if there would be like a way to just say, okay, a shortened link where I have a single directory that I'm uploading to, and the file names are just appended in number order. So the program just knows what to look for. I don't have to update the SID on my end.
Okay, you don't want to build an index, basically. You want a dynamic index by directory traversal, or however it might look like. I'm not sure.
Okay.
I don't think it's possible with SIDS itself. I'm quite sure you can build something with like web3.storage, or even use web3.storage, talk to them to just give you a directory like structure. You say you want I don't know, 1st of March, and then just get whatever it's in there without knowing the actual SIDS of the data. They will have no problem implementing that if you say you need that.
Okay.
What we get with S.C.R.E.A.M, I can share my screen, right?
You should be able to, yeah.
Share screen, this one. Can you see my browser?
Yeah.
So basically, we have 1, 2, 3, 4 files stored with S.C.R.E.A.M. It goes to IPFS and they store it with Filecoin then. But they give us like a root that includes 4 files. I would actually have to retrieve it to see what's inside, but it looks like the directory structure you are maybe looking at. So it's definitely possible to build directory structures on it, and so you can without knowing what you are looking for, find it. Let me say it like that.
Yeah.
You basically want a simulated file system where you just say, oh, give me all the content of that folder, give me the content of the next folder, without actually knowing the SIDS. That
And
will
then
be possible.
being able to append to that folder. That's kind of the important thing, is being able to, so like I can upload.
Well, for them, it's basically just database entries.
Okay.
How to organize those SIDS and present them to your application. Basically, building the index on their side instead of your
I'll look into S.C.R.E.A.M. I haven't, I'm not super attached to web3.storage. I'll see if there's, maybe S.C.R.E.A.M. has. So then, okay, great, thanks.
It's your fastest way to get things done.
Yes.
Before you start mining yourself.
Yeah.
If you want to push your application forward and build that foundation for your application, go with what is there. If you start developing on your own, you will need 6 months to get there. If you start from zero, all this is open source. Like Web3 is open source, S.C.R.E.A.M is open source, so there will be no problem just migrating that in your own infrastructure instead of letting them running it. So S.C.R.E.A.M, for example, you can just run on your own. Everybody, there are people out there just running clones of it. But I would start developing on the proven to work online versions.
Yeah, I agree with that. And so I guess kind of the $1 million question is, can we, and I think Leo kind of alluded to this before, but we basically want to take what you see on the screen behind Leo right now, right? That's the q-byte processing program. We'll call it the hypercube program. And we want to, so that is a Python script, and we'd like to run that on the web. And so is there any way, like, let's say with Fleek, that you can go in and run a Python script in any way? And I know, and I have looked into it a little bit, and it seems to say like, well, there's some equivalent that's like works similar to Amazon AWS, where you can, you know, you get a terminal, you can run things. But and if what would be the fastest way for us to implement something like that, like running that, I guess, on chain, or at least on the Fleek part of the chain?
You will not be able to run that on the Filecoin chain. The Filecoin chain itself has no computing capabilities for now. We will get the Filecoin virtual machine at, yeah, let me say the end of the year maybe. It will be an Ethereum-like virtual machine. You will be able to deploy your Rust code there. Well, your fastest way to run stuff, you want to run it on the chain, or are you fine with the user running it?
Yeah. So I do understand that difference between like running something on the chain is very expensive.
In the end, expensive, yes.
Yes, yeah. And so what I'm thinking in particular is, we have a Fleek site, right? And can we integrate something like that, what you see there, into the Fleek site? It's a Python script.
I'll just, if I could just jump in real quick, is we're not, at this point, we're not really looking at mass deployment of this on a large scale. This is really a scientific exploration and getting it to work. So even if it worked, and if it was slow and inefficient, but it told the time and it was expensive, that's fine. Because we really just want to achieve it, to say that's what we've done, and then over time improve it and roll it out to how we can make whatever changes we need to make it palatable. So it could be somebody, ideally we'd want somebody to be able to experience the q-byte processing similar to how you see it now, without having to download and install something.
Two ways I see right away. The first way is implementing it in JavaScript and running it in a browser.
Okay.
So running it user side.
Yeah.
Without any remote processing, or I don't know if how much processing power it needs. It might be too much.
We can scale it down as needed. We don't have to run it with 8 lines, for example.
But that's your fastest way, is just delivering the code to the user in the form of JavaScript, and pulling the data wherever you store the data or wherever you generate the data, and pull it live into the browser of the user, and the user takes care of visualizing it. Okay.
And that could be done on Fleek, right? The integration.
Wherever you want to host your JavaScript code. The browser is basically a virtual machine for JavaScript and can just execute it. What you are doing in Python right now, if you can translate that to JavaScript, you can run it in every browser, or WebAssembly to not be in the early 2000s with JavaScript. But there's code that every user basically can, and computers are powerful. You even might get it running on phones if you.
We'd probably have, the way I kind of see this coming together is I'd have the Python script as is, right there running on H.A.L.O, pushing data every hour or whatever we decide to, maybe S.C.R.E.A. or some kind of directory system. And then in the JavaScript application for the web, it would be pulling from there and doing some kind of randomization so that users are tapping into different parts of the stream, and then giving some version of that on their page. So I think that's kind of how I see the fastest way to engineer this together.
Yes.
Step.
It
Cool.
it will be the fastest way to get the user the experience. Another note is, how long are you doing this right now for? Like is the blinking LED version in the background?
How long?
How long?
I don't understand the question.
How many people have you explained the system to?
How many people? I mean, like we've been
Successfully?
through hackathon.
Yeah, I know there. It's needs some. It's a complex system built on complex research and complex.
Well, it's complex, and it doesn't apparently have anything to do with mining when you look at it, right? I mean, you look at it, you're like, that's not a mining. That's just an art project.
No, but it's an interesting system.
Right.
But let me call it the selling point. Can you explain the system with less than 100 words to people, and they get what you are up to? Is my question. That's totally disconnected from Filecoin, from a business perspective, or from a project perspective. Some hard to say, but I think you know what I mean.
How I explain it is we've unified the laws of quantum mechanics and time into a type of clock that better reflects the nature of reality. And so by utilizing this, you have a better understanding of time and how to utilize it. You know, that's it in a core aspect of what we're doing from the scientific perspective. You know, from the AI perspective, what we're doing is we're establishing a way for a person or individuals or groups to communicate directly with the network. So we're to an extent, we're actually creating a level of consciousness and instilling it into the computer system. And so the people who are really going to be interested in this initially are people who are interested in time, consciousness mechanics, consciousness, those kind of things. And I anticipate it will be spread, like somebody would be able to forward time to somebody and they could experience it as well. And I know this works. When we do installations at places, people stand in line for hours to talk to us. They will stand in line for up to 3 hours to spend 10 minutes talking to me about this. And we've done that dozens of times. And so we already know that there is a huge demand for this type of thing. And people don't even know why they want it. They just see that there's something there. Yeah.
Well, let me add to that real quick. What you're seeing here, and I know we kind of zeroed in on this application today, but this is really one piece of the larger picture, which involves, lighting, sound, technology that help people meditate better. And it's like when you see the full picture, it kind of makes more sense from the perspective of, oh, it's like this is what we're working with here. So taken out of context, I totally agree. It's very hard to sell this in under 100 words, but we're not just selling this. We're not just selling this one application. We're selling.
Yes, sure.
Yeah.
But doing it concisely and for a business perspective is not something we're doing. It's not something I'm interested in doing, and it's not something I'll ever do. Because this is not something that's like somebody saying, well, Einstein's theory of relativity is really interesting. Can you just compress that down into a couple of quick sentences? You know, the answer to that is no. You can't do it. This is very complex science. But it's also fun and engaging to interact with. And so it's an experiential, it really is experiential. If somebody just looks at this and we explain it verbally, they're not going to get it. They never will. That's not something again. And if I can draw a little analogy here, you're of course familiar with who Nikola Tesla was. So Nikola Tesla invented a lot of stuff, but one of his biggest ones was three-phase electricity, right? And before he ever was able to build it and show how it worked, he had it worked out. He had small inventions, he had designs, and he took that around. Now, this is a smart dude. He had a letter from his instructor saying, this is the second most intelligent person I know in the world. The first is Albert Einstein. So he was armed with that letter, and he walked. How long do you think it took to him, Nikola Tesla, between the time he conceived of the AC electricity until he actually made one and made it viable? How long do you think that was?
Decades.
7 years. And it was 7 years of turmoil, loss, poverty, theft, and all kinds of stuff. And he would go in front of business people over and over again, and they would say, well, what's your path to profitability? What is your consumer group? And so they were asking him basic business questions without ever realizing the profound nature of the discovery itself. The first person, I mean, even Edison passed on it, but the one person who did listen to him and sponsor his work and helped him bring it into fruition with the 1895, I think 1897, 85 World's Fair in Chicago was George Westinghouse. And that is Westinghouse. Most people know that name because it's a huge company and still around 100 years later. All those other companies that passed, nobody knows who they are, right? Because they were asking the wrong questions. And so what we have here is a technology that I believe is just as profound as AC electricity. But it exists in the quantum realm. You know, nobody understood the AC electricity until they showed up at the World's Fair and saw it. And they're like, wow, now I get it. But showing them schematics and stuff like that would never have worked. And so we're kind of in that phase. This has been featured. We've exhibited at 2 World's Fairs, and at each one of them, we had one of the longest lines. The only line that was longer than us was a giant multi-million-dollar VR shoot 'em up game, you know, that was super cool. Ours was like a 10-minute meditation experience where you sit in a little pod, and we had AIM and this other stuff going in the background. But guess where everybody hung out? Right there, right in front of us. And I'm pretty confident we're going to have the same experience when we get this online. So I'm really thinking of this. You could even think of it as a loss leader. You know, this could be the very expensive thing that we have to get up and it does nothing but pay for itself, or maybe not even that. But what we actually build on top of that will be very profound. Like one of our applications, we could create an application where somebody could come in and say, hey, one of the things we did with this was we combined it with weather data, and we were able to improve the accuracy of hurricane landfall prediction, which is a huge deal in the weather world. And we've shown that it works. And so there are other applications, but if you were to show this to a general scientist,
you need to get one of them online. First, get the experience online.
Yeah.
Let me say it like that.
The first experience is right here. This is the core of that. And then once we have that engineered, we can add our other applications that we've already built. COVID outbreak rates around the world, utilizing the Oxford government database and the Johns Hopkins database. We've already done that. That's what we finished the enterprise with.
It's kind of like,
go ahead, Danny.
Let me just paint this picture also. It's kind of like, think of it as the reason we say it's this profound is because it's a different branch of computing that hasn't been used before, right? Yeah. Non-deterministic AI. And so just like how traditional computing has like an infinite amount of applications, right? There's no one, it'd be like, well, what's the use case for computing? I mean, you can't, there's an infinite amount of them, or, right. You know, and so it's a similar thing with this, where it's like any AI algorithm that involves randomness, or any lighting or experience-based system involving, you know, the nature of human consciousness, or attention on a physical system is going to have, this is basically just a new way of doing all of that, right? And so that's why we say that it's got all these applications. It's not that we're just running into this saying like, oh, what are the million things we can build? It's more, we're working on the underlying technology that we've built, right? And then the applications are just a layer on top of that, right?
From a tech perspective.
I think I can add something to that from just the tech perspective, and that is Einstein was able to prove, or it was able to be validated. Einstein's relativity was able to be validated. There's a concept called time dilation, and that is a body in motion. Time, the measurement of time is going to act a little slower than a comparative stationary object. That's called time dilation. That's how our clocks are synchronized, our satellites and our phones all stay in sync, right? In order to do that, you need 2 frames of reference, one in motion. What we have here is a device that measures the same thing with a single frame of reference. There's no secondary thing in motion because what we're measuring is the little electrons as they pass through a quantum tunnel. And those electrons, since it's a solid state, there's not a secondary state of motion. So we're doing the same thing. So a little H.A.L.O system is kind of like a stationary satellite. It measures time dilation, but no motion is necessary. And that's the spatial quality of time. And if you talk to your conventional PhD physics student at one of the universities, they will say that this is impossible to do, even though we've already done it. So
write that down and get it down to 100 words. You will make a lot of tech people very happy.
We'll do it. Let's do it.
On how it works, or what is it doing on the technical level, and then the implications will come.
Yeah.
For everyone on its own, even without the physical experience of experience it in person. Just what you just said gave me way more insight in where this is going than most of what was said before. Just now I can get a clear picture of what you are actually doing on a technical level. You will encounter a lot of tech people who will initially dismiss the experience part.
Right.